Hey everyone, welcome back to another episode of the Space Roundup with space experts and astronomers Nick Howes and Terry Moseley. Hey Nick and Terry, how are you guys doing tonight?
Very
Hi.
good. Very
good to be back.
Awesome. Thanks everyone for joining us, whether you're on YouTube or Facebook. Remember, you can interact throughout the show within the comment section. Let us know if you have any questions. Nick and Terry will be very happy to answer them. And tonight they're going to be bringing you what's been happening in the world of space. I hope you guys have a great show, and I'll see you towards the end. Take care.
Cheers, Latch.
Cheers.
It's a busy one. We've got some interesting kind of discussions in the WhatsApp bit as well, because finally being able to get out and do some real observing, so that's going to be quite nice tonight. But we're going to start with the hottest topic on the planet right now, which is COP26. So this is the kind of big global climate conference that's happening in Glasgow in Scotland in the UK, not as CNN seem to think it is in Edinburgh in Scotland in the UK, which is quite amusing and quite bizarre. But Glasgow is hosting over 200 countries from around the world, talking about the impact of climate change and the very serious threat that's looming with this. Now, COP26 obviously is focused on what's happening on the Earth and the devastating effects that we're seeing already with climate change, and some nations, representative nations like Bangladesh, etc., are really starting to feel the impacts of this. So the whole argument of is it real or is it not real? It's real. One of the key things with the whole of climate change and climate observation is the role that satellites play in this, because satellites obviously give us some of the key data that we get in terms of monitoring things like glacial changes, sea states, even plastics in the ocean, whale migration, deforestation, which was a hot topic in the last few days in terms of how many acres are being lost in places like the Amazon, and these commitments now from various government bodies to say that they're going to stop all deforestation. We believe it when we see it, because we've heard promises like that before. But it's interesting, we've got currently 4,550 active satellites now in orbit around the Earth, not including the 130 to 180 million pieces of debris, but active satellites, over 4,500 now. What's interesting out of that 4,500 satellite list is only 680 approximately are being used for Earth observation, scientific Earth observation, obviously, and spy satellites as well. So of the 4,500, 2,800 of those are from the United States. Only 167 satellites currently orbiting the Earth are Russian. Around about 430 are Chinese, and then about 1,150 or so are all of the other nations around the world. Now, the IPCC, the international kind of intergovernment body that talks about climate change, really focused on the importance that satellites play. As I said, if you wanted to monitor deforestation in certain regions around the world, it's next to impossible to do it on the ground. It could be due to a whole number of reasons. Accessibility, it could be really tricky to get there. Obviously, low altitude flights over some locations are next to impossible. Certain nations don't like you flying over them at low altitude, some of our NATO enemies, as it were. We'll go on to that in a bit, in a while. But the use of what's called GIS, global information, geographic and global information systems, which has been, for decades now, a really key part of what we're doing with science, is all being generated by satellites. And yet, they're talking about the impact of climate change and the impact of this and the impact of that and the financial impact, obviously, of climate change, as well as, the actual ecological disaster that's happening. And the irony of people like Jeff Bezos flying in on a private jet and then having a multi-car motorcade taken from the airport doesn't escape anyone, I hope. It's just ridiculous. The carbon footprint for this conference is just ridiculous anyway. But what people aren't really focusing on, it's quite upsetting in some respects, in that European Space Agency do have a fringe event and fringe kind of setup there, not in the main conference area, but in the green zone, etc., and the kind of key areas where a lot of the delegates will be focused. There isn't much space activity or awareness of what space is able to bring to environmental and climate monitoring, and also the effects of what will happen if it all goes wrong. And it kind of brings us back to our oft touched on discussion of collision events and this whole thing with debris, and we're throwing up more and more and more and more satellites. Terry and I were talking just before we went on air, and Amazon have now started launching their satellite constellation, which is 3,500 3,200 to 3,500 satellites. China's 13,000 satellites are now, well under planning. Starlink is gathering at pace. Last time I looked at the UCS database a few months ago, it was 4,100 satellites. Now it's 4,550. So we are clearly launching at a staggering pace. The other thing that's been talked about quite a lot recently is space weather and the impacts of space weather. There's an article just today on the radio, on Radio 5, talking about the impact of space weather. And it's a real thing. People go, what's space weather? Well, our nearest star, the sun, is emanating a lot of plasma. And we had a really nice ejection on Halloween just a few days ago. If you're listening on catch up, or if you're listening live, it's a few days ago now to Halloween, which caused auroral displays in lots of parts of the UK. So the sun is very active, and as it's now kind of getting closer to its normal levels of activity, so we've had a really quite quiescent period with the sun for a good few years now, but it's getting back up to normal activity. The impact on these satellites could be, again, catastrophic. And I just hope that the governments around the world are seeing this and seeing that environmental impacts and disasters, if we want to avoid the real one, we've got to avoid this space disaster happening. Because if this happens, if this Kessler or catastrophic solar storm event happens and it knocks out so many of our Earth observation satellites, we won't have the means to monitor and validate if these countries are keeping to their plans. Countries that say that they're going to reduce their coal emission or the coal use, etc. We won't be able to check this. So it's an incredibly important thing that I just hope, if anyone is listening who's up at COP26, we've got lots of friends in various parts of the space sector I know do listen and catch up, etc. Please try to reinforce this. Our new science minister in the UK seems extremely good. Seems to really know what he's talking about. So it's people like that we really need to impress this upon, that they need to understand, yes, the benefits of space. There are huge benefits in terms of Earth observation, but just throwing up masses of constellations to try and compete with Starlink is not one of them. I don't know, Terry, thoughts on the whole COP26 fiasco? Conference?
Sorry, I'll ignore that, although I tend to agree with you. It's not just sort of keeping an eye on what other countries are doing. It's actually very, very important for each country to see how they are managing themselves. I mean, it's essential now for agriculture. Satellite imaging can tell you, for example, whether there's a mineral deficiency in one half of your field and you need to apply fertilizer there, not the other side. So there's so many things now that the satellites are essential for. And if any countries are genuinely trying to live up to their promises, whatever promises they make as a result of this conference, they will need satellites really to make sure that they are delivering. There's so many things. An awful lot depends on ocean currents and so on, for example. And that's really the only satisfactory way of monitoring those from space. But I think in agriculture in particular, because it's a great contributor to not only CO2, but methane. And to monitor your agriculture on a large scale, the only way to do it effectively is by satellite. So if we lose the satellites, as you say, not only can we not know what other people are up to, we can't even see what we're doing ourselves. So it is absolutely essential that we mitigate against a possible Kessler effect.
And it's interesting as well that Elon Musk has announced that he's going to donate $6 billion to kind of help end world food poverty and, help with some of these impending disasters. Now, it could be a PR stunt or it could be a genuine thing. Who knows? But I mean, it's a welcome amount of money. But then, $6 billion from Musk, $2 billion apparently has been promised by Bezos. It sounds like huge sums of money until you put it in the context of other things that we like to spend our money on. Like in the UK, we're currently spending £110 billion, which is around about $150 billion. On a train line called HS2, which is also decimating ancient woodlands and ancient trees. So that's one issue there. And then the US Department of Defense's budget last year was $718 billion. Now, $6 billion, as I said, it's a fantastic amount. Please, don't get me wrong in terms of it's wonderful to see these space billionaires donating, or two of the richest people on the planet donating some of their money. And you only have to look at obviously what Bill Gates has been doing for many years with his attempts to try and curb malaria, for example, Bill and Melinda Gates. But we've really got to put this into context to really solve these issues. A few billion here, a few billion there, whilst it is a great start, is not going to solve these problems. And the UK space program, for example, the amount of money that's been invested into that is only in the tens of millions from the UK government. And apart from OneWeb, which is a satellite constellation of over 600 or 500, 600 satellites aiming at competing against Starlink and giving us sovereign GNSS capability, which we already had with Galileo before we pulled out of Brexit. So the impacts, without getting too political, we've really got to step away from the politics of this and look at the science. The scientists are the people who are leading the world in terms of, COVID response is science. Science has saved us. In terms of the climate impact, it's going to be science that saves us again, if at all, if we're not too late. So please, politicians, please start listening to the scientists, because we need you. We need you to. Just before I move on to our next item after this one, which is a happy way to start, we're seeing that one of our regulars who listens in has named two of his telescopes Nick and Terry in Kerbal Space Program. So to Ground Based Space, thank you. That is a real honour. That's really, really nice. So moving on, which I think is really, really cool, to our next story, Cosmic Goldmines. This one's for you, Terry.
Yeah, I just hope that wasn't the kiss of death for those two telescopes. Anybody who has ever given an astronomical lecture will probably have said at some stage that the gold in your rings, or if you're a rock megastar and your bling that you have all around your neck and everywhere, was produced in a supernova explosion. Now, we're going to have to revise that slightly, because this is some very interesting new research. It's not untrue, but we now find that actually the main production of gold and other very heavy metals is not just in supernova explosions, but in the mergers of neutron stars. And this is all really absolutely new stuff. I mean, neutron stars were predicted a good while ago. Some of them have been observed and so on. But the idea of merging and what would happen whenever two neutron stars emerge is just sort of the very latest cutting edge science. So, yes, let's go back to the beginning. When a really massive star nears the end of its life, it basically blows off its outer layers in a huge explosion, a supernova explosion, and the rest of it collapses and forms a white dwarf, or in a really massive star forms a neutron star. And we know about those. We've observed them. There's one in the middle of the Crab Nebula and so on. You can find out a lot more about them on the internet. But during that explosion, it was thought that all of the elements heavier than iron were produced in those explosions, because without going into too much of the nuclear physics, ordinary stars produce all the elements up to iron in their normal thermonuclear fusion. But what happens when you reach iron is that it takes more energy going in than is produced in the fusion, so the process stops there. And again, it gets a bit complicated, but basically that's what leads to the ends of these big massive stars. So yes, a certain amount of gold and other heavy elements is produced in that process, but some new research shows that actually far more is produced whenever you get two neutron stars merging. And that's not all that rare, because a huge number of stars in the universe are not single stars. They're binaries, or in some cases triple or quadruple and so on. So there are a large number of binary stars out there, and it's quite possible that both of them will end up as neutron stars. And again, in due course, those two neutron stars may merge together, giving you an absolutely colossal explosion. And the latest research indicates that that is where all the metals heavier than iron, and the ones that most people like to talk about would be gold and platinum and maybe even lead and uranium, other ones that people will know about. That is where most of them are produced. There was another theory that said that actually if you had a neutron star merging with a black hole, that would also produce a large number of these very heavy metals. And yes, that latest research indicates that that's the case. But in many cases, the black hole will actually swallow up the neutron star before it gets to the point of producing these heavy elements in an explosion. So just to give you an idea, there was one neutron star merger that was observed particularly well, and they reckon that the merger of those two stars produced an amount of gold in mass several times the total mass of planet Earth. So Goldfinger would have been in his element if it'd been out in that area there. So it's just the latest stuff. It's a brilliant time to be interested in astronomy and space because there's new research, new developments happening all the time. I just thought that was a really neat one. So Nick, you and I will both have to slightly revise our public lecture presentations on the production of the heavy elements.
Indeed. And I like the Auric Goldfinger one. You could basically say, when you've got a gravitational wave, no, I'm expecting you to die.
Yeah.
If you remember your Goldfinger movie. It is really fascinating. The thing about neutron stars as well, for some of the audience who may not know, and the fact that always used to grab me when I was a kid was that a teaspoon of neutron star material is way about the same as Mount Everest. It's one of those kind of remarkable things that exists and is there because we've got direct observational evidence and have had for decades now, as Terry was saying. Whereas with black holes, for example, we only inferred their existence up until quite recently, when again we've got now direct observational evidence of black holes and the accretion disk around them. But to know that so much of everything that we touch from a day-to-day basis, the whole David Bowie, we're made of stardust kind of thing, it's true. It really is true. So it's one of those things that if you get married in the future and you have exchange of gold rings, who knows, it could have been formed in a neutron star merger. It's quite amazing. Anyway, good story. I like that one. Moving on to another cracker. This is another one that Terry actually found. Oh, hold on, my computer is saying my battery's running low, so I'm just going to plug that in. 2 seconds. And switching that over. There we go. All good. Cracking story, this one. So this is another one that Terry picked up on. M51. So there's a good history of M51 as a galaxy. It's a galaxy that's around about 28 million light years away. So not one of the ones that you can typically see naked eye. In the mid-1800s in Ireland, at the behest of a chap called Lord Ross, who was really into observational astronomy, he built a gigantic telescope known as Leviathan that Terry and I have both stood in. It's quite amazing. When we were invited to give a tour there, we've got a great photo of the two of us standing in the front of this behemoth, recreated behemoth of a telescope. And it was where some of the first observations of galactic structure took place. And some of the original drawings there in the house and museum. It's a fascinating place. If you ever get a chance to go over to Ireland, definitely go and visit it. It's wonderful. So this place where galactic structure was first seen has now been the first location where an extragalactic exoplanet has been detected. Now, you think about the complexity and the difficulty in this. What you're looking at is, even with the nearest star system to us, with Proxima Centauri, and we've now proved that there's exoplanets orbiting pretty much most stars. I mean, it's 1 in 10 from telescopes like Kepler, which has been in orbit, and looking at these transit events where what happens is a planet will pass in front of the star and the light from the star will dip due to the planet basically passing in front of it. So larger the planet, the bigger the dip, etc. If you've got multiple planets, you'll see multiple dips. So that's one method. The other method is using spectroscopy, where you're looking at spectral lines and you can see changes in the spectral lines and shifts in the spectral lines caused by the gravity of orbiting planets. So, interesting methods, both of them. But from an optical standpoint, even at the nearest star system, which is just over 4 light years away, recognizing that something, the Earth, for example, could be swallowed up by the sun 1 million times. So it's 1 million times, the sun in terms of its mass is 1 million times larger. So if you had a small planet the size of the Earth orbiting in front of the sun, and you were trying to look at that from 4 light years away. Now, don't forget, 4 light years, you've got 186,000 miles per second. There are 86,400 seconds in a day, 365-ish days in a year. And then times that by 4.3. And essentially, that's how many miles you're talking about to the nearest star. And these stars outshine and are far brighter than anything else in their vicinity, obviously, because planets don't have natural light of their own. They just use the reflected light from the star. So even detecting this, which was first done in the 1990s, and we've now got over 4,000 exoplanets in our own galaxy, is an incredibly difficult challenge, but one that even amateur astronomers are now able to do. from the back garden telescopes. If you've got a decent sized back garden telescope, you can take part and see these light curve dips because the quality of cameras, etc., is getting so good. So this detection, however, was using an X-ray or combination of X-ray telescopes. This was the Chandra telescope run by NASA and XMM Newton, which is run by the European Space Agency. And if you want to see one of those, XMM Newton, if you go to the Toulouse Space Centre in France, if you ever get a chance to go there, they've got a full-size model of the XMM Newton out in the grounds there. So it's a big telescope. Now, the thing about X-ray radiation is that it's at the kind of higher end of the frequency spectrum, so shorter wavelengths, etc. And technically, therefore, you should be able to get more precise observations. It's still incredibly complex, but what this team did, based at the Harvard-Smithsonian Center for Astrophysics Research, what they did was they pointed at M101, M104, M51, three relatively nearby galaxies, and they were looking for these dips, and they found one. So this planet is known as M51 ULS 1b, snappy name as we know. Really, really remarkable discovery using this transiting method. It's hopefully going to open up observations of a plethora of extragalactic or, pan-galactic, but extragalactic exoplanets. And based upon what we've found with Kepler and the sheer number of exoplanets out there, the question then begs, again, it goes back to the fundamental question of, are we alone in the universe? And no, we're not. There's absolutely, it'd be crazy to even think that we are. If you think that our galaxy has got approximately 250 billion to 400 billion stars, each one of those stars is capable of hosting, like our sun is, 8 planets that we know of. Right now. And then if you times that by 250 billion times 8, that's potentially just for our galaxy. And then you've got 250 to 400 billion known galaxies in the observable universe. So to think that we're alone and we're the only life form is just crazy. It's literally crazy talk. The interesting thing, as I keep coming back to this, is that even with Proxima Centauri and the Alpha Centauri, Proxima Centauri system, the fastest spacecraft humankind has ever developed or designed would still take in excess of 4,000 to 8,000 years to get there at the current speeds that we can travel at. So hopefully in the future we'll have hypervelocity, vehicles that can go possibly up to 1/10 the speed of light. That's been speculated for quite some time using nuclear drive, nuclear propulsion, or even kind of solar sails, just gradually accelerating these spacecraft. And hopefully at one point we will be able to detect not only the exoplanets, which we are doing, but the really detailed observations of the atmospheres of these exoplanets. Because if we find an exoplanet in the Goldilocks zone, so that kind of region where it's not too hot like Venus and not too cold like Mars, where we are relative to our sun, orbiting another star system, and then we detect in the atmosphere of that evidence that potentially there could be life, from some organic, detection in the atmosphere of that planet. What do we do then? That's the big question, because that life could be very primitive. It could be just plant life. It could be, it could be something as advanced as a dolphin, but still not able to communicate with us in a method that we would understand. And you look at SETI and some of the radio observations that have been going on for many years, and I admire, people like Frank Drake, the Drake equation, working out the possibility of life, and so many people have worked on the SETI program, Seth Shostak, etc., for many, many years. But if you think about it, the entirety of human history, where we've been an intelligent, sentient species that could really think and, perform calculations and do things, is maybe 10, 20,000 years. Our ability to transmit and receive radio only started around about 160 years ago, 170 years ago. And we've only had the transmitter capability in the last maybe 80 to 100 years to be able to reach out to these far-flung star systems. And then right now we're reducing our use of traditional analog radio, etc. So the whole thing of listening for radio waves, there could be something out there, but I think there's got to be a better way of detecting, potential life. But as a discovery, this is still amazing. Terry, you found this story. What are your thoughts on this?
Yeah, I think we need a slight caveat. They're only, 95% sure that this is a planet. There's no other thing that they can think of that would produce the particular dip in the X-ray emission. But the object, they reckon it's about the size of Saturn, but it's about 20 astronomical units, or 20 times the distance of the Earth from the Sun out in its orbit. So it's a very slow orbit, and it'll take about 70 years before it will come round again to do another occultation of the X-ray source. So you can't be really 100% sure until you get a complete orbit. So they're not totally sure, but there's certainly no other explanation available at the moment that matches the dip in the light curve. But as you say, that this is just absolutely fantastic to be able to detect another planet 28 million light years away. I mean, it's mind blowing, just mind blowing.
It really is. The mileage calculation. Yeah. As I said, it always, even if you look at things like New Horizons and the extreme velocities that was launched at, and the relatively short period of time it took to get out to Pluto, compared to the Voyagers, obviously with their grand tour of the solar system back in the 70s and 80s, it's still somewhat depressing in many respects to realize just how vast space is. But then, going back to our first story, if we were to clutter up low Earth orbit, we won't be launching anything anyway. We won't be doing any exploration. So anyway, moving on. Next story. Again, another absolute corker. I love this one.
Yeah. My favorite planet in many ways. Saturn is the most beautiful one to look at in a telescope, as we'll talk about later. But the most interesting one to observe, certainly for me anyway, is Jupiter, because it's always changing. And I spent many, many hundreds of hours, literally, observing Jupiter when I was in my late teens and early 20s, before I discovered women and things like that. And it really is absolutely fascinating. Whole lot of things about it. First of all, it spins on its axis in less than 10 hours. So if you get a good long clear winter's night, you can see the whole planet rotate before your eyes. And this is a thing big enough to hold 1,000 Earths, and yet it spins so incredibly quickly. There's features like the Great Red Spot, which I'm going to talk about, which have been there for probably centuries, big enough to contain several Earths. They're the constant dance of the satellites around it and so on. So it's an absolute delight for anybody that has a reasonable telescope to observe. Things move, things change, things that rotate at different speeds. They get darker, they get lighter, they disappear, new features suddenly appear, and so on. But the Great Red Spot, possibly recorded back in the 17th century. We're not absolutely sure, but it's certainly been there for at least several hundred years. And this thing is humongous. It's basically a gigantic whirlwind in the atmosphere of Jupiter. And as it says on the tin, it's great, and it's also red or sort of pinkish. Sometimes the color varies as well. It can be anything from red to sort of light salmon pink. And it's there, and it's not visible every night, because sometimes it's transiting whenever Jupiter is either below the horizon or in daylight. But if you observe for a couple of nights, you'll definitely see it in any reasonable telescope. And I used to try and measure the size of it in a very primitive way then, but it was the only way available, by timing when the leading edge and the following edge actually crossed the central meridian of Jupiter, the line joining the north and south poles. And back then, it was much more elongated. It was longer in sort of relation to length and diameter than a rugby ball or an American football would be. Now it is shrinking, mainly in length, so it's now more like egg-shaped. So even sort of in the last half century, there have been significant changes in it. And some people have speculated that it's going to disappear altogether. But now, of course, we not only have things like the Hubble Space Telescope, we have had a whole lot of spacecraft going there. And at the moment, Juno, a NASA spacecraft, is in orbit around Jupiter, and it is making detailed observations. And it has found some absolutely fascinating details about the Great Red Spot that we can't really get from Earth. From Earth, we can basically only see the surface of it, but the Juno spacecraft has microwaves that can operate at several different wavelengths, and they can penetrate down right into the red spot and the surrounding area. And they have found that it extends down to probably around 300 miles deep from the surface down into the atmosphere. That's mind-boggling enough. Imagine, if you like, sort of a hurricane on Earth, which is bigger. Well, you can't imagine it on Earth, but it's bigger than the whole Earth, and it's also about 300 miles deep. What's even more fascinating is that the cloud belts surround it. And this thing keeps circulating basically because there are two atmospheric currents, one to the north of it and one to the south of it, and they're traveling at different speeds. So they're sort of making it rotate as they travel around it. Those extend down to a distance of probably about 1,800 miles down into Jupiter. One thing we should bear in mind, of course, is that Jupiter doesn't have a solid surface the way, say, Venus or the Earth or Mars have. It may be solid down in the very core just due to the extremely high pressure. But there's no solid surface as we understand it. The density of the atmosphere just gets greater and greater as you go down, and then it possibly turns slushy. And then in the very middle, there may be a metallic core. But in terms of the atmosphere, basically it just gets denser and denser as you go down. So we have this huge whirlwind circulating around. So I'm getting a bit of feedback here on my earphones. I'm not sure what it is, but I'll keep going anyway. At least 300 miles deep and being surrounded by other currents in the Jovian atmosphere that go down 1,800 miles deep. Again, these things are just absolutely mind-boggling. Some other things, as it shrinks, it's actually getting slightly taller. So that could be just a redistribution of the mass. It no longer has the same sort of horizontal area. The material that's forming it, whatever it is, different chemicals, probably mainly ammonia, is getting squeezed, so it actually extends up higher into the atmosphere, and that the clouds spinning around the outside are now moving faster than they used to, but the currents near the center of the Great Red Spot are spinning more slowly. And it just shows you the benefits of having a spacecraft there on the spot. We'd never be able to detect that from planet Earth. So an absolutely fascinating object, and the more we find out about it, the more intriguing it is. I'm sure you've enjoyed looking at it many times yourself, Nick.
Oh, absolutely. And I've just posted a link into the chat which shows some of the shrinking of the Great Red Spot, and that's been taken by amateur observers. So again, Terry and I, before we came on air, we were talking about observing Jupiter, and the amateurs in the past maybe 10, 20 years, people like Damien Peach in the UK, Christopher Go out in the Philippines, Paul Hees in Australia, are doing absolute, and there's so many more now because everybody's getting into very high quality cameras. The quality of the cameras and the high frame rates that they can deliver, and the filters that are now available even to amateur observers, and we're not talking about small investments here, we're talking about several £1,000s worth of telescopes to get images of the kind of quality that you'll see if you do click on that link. But it's now amazing that amateurs are donating so many images to professional scientists. And when Juno wasn't at Jupiter and there was nothing really orbiting Jupiter, getting time on the Hubble to do observations was obviously very tricky. And so a lot of the ground-based telescopes, they're not specifically targeting planetary observations. The big telescopes around the world, they're looking at comets or asteroids or galactic observations, etc. So planetary observations, the amateurs do play a huge role in this, especially when you're looking at consistent monitoring. And you look at the Great Red Spot, the image in that link is a kind of a simulation of that shrinkage that Terry was talking about during this article. But also, Jupiter is 1,000 times the size of the Earth. It could swallow the Earth 1,000 times, and it acts as almost like a gigantic vacuum cleaner for the solar system. And we've got, we talked last time about the missions going out to now look at the Trojan asteroids, which are, orbiting ahead, Trojans and other asteroid groups that are orbiting around Jupiter, which we're trying to get more of a handle on and more information on over the coming decades. And to see that the amateurs are delivering these remarkable images, when we don't have spacecraft, like Juno's there at the moment, but when we don't have spacecraft there, it is incredible because they can also detect things like asteroid and cometary impacts on Jupiter's upper cloud deck. And these have been detected by amateurs on multiple occasions now, where there's an alert network almost where amateurs are saying, look, we think we've got an observation where we're showing an impact on the surface of, the upper cloud decks of Jupiter. It's no actual surface, but the cloud decks. And then the professional observatories will then target that to see if there's any kind of residual aftershock, as it were, if there's any disruption in the cloud layer or any pockholes that you had with, Shoemaker-Levy 9 when that hit Jupiter a few decades ago, leave these gigantic scars on the upper cloud decks for several revolutions. But as Terry said, it's fascinating because you can see not only Jupiter itself, rotating in a matter of 10 hours, but the moon's orbiting. You can see the shift in position. And this, these are going back to the days of Galileo and some of the first observations of Jupiter with very, very simple telescopes. You don't need anything spectacular to see the moons. A pair of binoculars will do it. And you can see these 4 Galilean moons, Io, Callisto, Ganymede, and Europa. And you think, well, Europa's this ice world that potentially could host life. And Io's this phenomenally volcanic active body, the most volcanically active thing in the entire solar system. And you just got to let your mind wander. So adding to that, these incredible observations from Juno, and I had a lot of a problem with Juno when it first got there because the principal investigator, the lead scientist on it, said it was the greatest thing and it beat the Apollo program. I was like, well, no, it didn't, but it is still a remarkable achievement, the Juno spacecraft, how close it gets and the braking maneuver it had to do to get into orbit around Jupiter so close. So well worth following on, well worth keeping up with what Juno's delivering, because it's almost like the forgotten child of the solar system. We hear a lot from New Horizons still, Alan Stern and his team still doing great science there, and we hear a lot obviously from the Mars rovers and Mars observations, and we're hearing now from Bepi Colombo reaching Mercury, and people tend to almost forget about Juno is orbiting Jupiter, because Jupiter's obviously been orbited previously and flown by on several occasions with the Pioneers and the Voyagers in the 70s. So it's a great planet to see, as we'll talk about during our look up section. But anyway, moving back to a slightly closer to home and a bit scarier story. Our next one, space war. So we've had the release this last week of June. I think it's the 3rd attempt now taking Frank Herbert's incredible novel and putting it into kind of film or cinematographic form. It is very good. It's the first time I've actually enjoyed watching anything to do with Dune, because that film in the 80s was absolutely dreadful. But this one was quite good. But it talks about kind of galactic conflict, and it's obviously been a theme through science fiction since science fiction's been there, really, with Star Wars and Battle Beyond the Stars and Battlestar Galactica and all this. But it's now becoming a reality, and we've had the James Bond kind of space war with Moonraker, where you've got 2 shuttles and teams of soldiers flying out of the shuttles with their backpacks, their MMU style, Bruce McCandless style of black backpacks firing lasers at each other. But it's now becoming a serious problem, a real genuine threat. Not in the way that we probably understand it. I mean, in the 1970s, the Russians managed to put a cannon, even though there was an international ban on the weaponization of space, they managed to put a cannon on one of their space stations, which was quite a terrifying thing. And there's been talk, obviously, all throughout the 1980s under Ronald Reagan's presidency. We had the Star Wars program and space defense, the Space Defense Initiative, SDI, and the concept of using lasers then. And then since then, we've had the Chinese, the North Americans, and the Indians performing what's called ASAT, anti-satellite missile tests, where they've launched a missile from the ground to knock out a satellite in orbit, which is staggeringly stupid on so many fronts, because, again, it's just increasing the debris problem. Now we've got an additional threat, which, I mean, I work in the defence sector for a big British defence company where we look at some of the aspects of space research, and this has been something that's been flagged up on our radar, pardon the pun, for quite some time, in that it's now been demonstrated, and there's still denials going on, obviously, at government level, but it's pretty conclusive now that China are launching what's called hypersonic missiles, so hypersonic glide vehicles. So this is almost like a mini space plane, launches like a conventional rocket. And then, unlike an intercontinental ballistic missile, which will go into space, go into quite high altitude, and will be picked up by NORAD and other radar detection systems, so they can get launch trajectories and they can get final trajectory on the incoming missile. If you've seen the movie War Games, you'll have seen all of that in action. These kind of skim in that tentative area at the very top of the atmosphere, the kind of interface boundary, the Kármán line area of space. And therefore, they evade this kind of detection because the atmosphere is still thick enough for them to perform dynamic maneuvering. Now, if you've got an object that can maneuver at literally anywhere between Mach 8 times the speed of sound, and Mach 20 to 21, which is what the Russians are also claiming, you've got a real problem, especially if you've got like large aircraft carriers out in the Pacific or large potential targets. Now, China are doing this, and it's kind of been described as a Sputnik moment. And if you remember in 1957, when Sputnik first flew over the United States, everyone got really scared. because they realised it was the height of the Cold War, approaching the height of the Cold War, which was a few years later with the Cuban Missile Crisis in the early 1960s. But everybody got really scared because they thought, well, if the Soviet Union at the time can put up a satellite, which was Sputnik, and it can go beep, 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 it could have a bomb or a missile in it. Now, what's happening with these hypersonic glide vehicles is China have been able to demonstrate what's called fractional orbital bombardment. So essentially they can deploy from orbit potentially not just one weapon, but multiple weapons. Now, this is not something just the Chinese or the Russians are doing. The United States are obviously looking at hypersonic vehicles as well. And, you can go on all sorts of conspiracy theory websites or look at the real data. But some really interesting work. But America's approach is non-nuclear at the moment that we're aware of, in that they want a strike capability. But it's still scarily moving towards almost like a taking space as a new battleground. And this has been highlighted by the fact that the US Department of Defense set up their Space Force, and it was kind of laughable, and it looked almost like a TV sitcom with the uniforms, and the trousers in the uniforms were particularly amusing. But taking all the frivolity aside, it's becoming more and more of an issue. And again, this goes back into our, we've got so much up there already. And if we were to create, a space war, as it were, where we're trying to shoot down these things when they're being tested in low Earth orbit, or if they genuinely become a threat, again, the catastrophic impact of a war would be enough, to send shivers down most people's spines. But if you then realize that the amount of junk that could be created by the destruction of things up in orbit on this kind of scale could prevent us from launching anything for hundreds and hundreds of years. We'd be stuck on this planet. And don't forget, the planet's warming up with climate change. So again, can we stop doing this, please? This saber rattling. I don't know what your thoughts are, Terry, but it just, working in the defense sector, it kind of terrifies most people.
Yeah, you'd know more about that angle than I do, obviously. But what amazes me is that there is actually a UN treaty on the peaceful uses of outer space, which basically bans using space as a sort of a battleground. But since when was a treaty ever any sort of ban to actually doing something if you intend to do it, as certain small European countries found out in the late 1930s? Doesn't matter what you sign if you want to actually do something different. Yeah, it is worrying because there are a whole lot of different ways that you can use to sort of disable your enemy's satellites. Some of them are less destructive than others, but almost all of them will eventually result in an increase in the amount of space debris. And, there's a sort of a temptation, if you think that somebody is going to disable your space capability, that you launch your nukes first while you still can. And it's a very, very dangerous sort of situation to be going into. More than that, you're really getting into the politics of it, which I don't want to do. But it really would be good to see everybody adhering to entirely peaceful uses of outer space.
That's the thing, because you look at, we've talked about this, and I know you're a huge fan of this as well, Terry, as I am, of the Chinese space program in general. Yep. The remarkable work that they've done in lunar landers and the Mars lander and the Mars rover. And we just want to see that continue rather than this ridiculous saber rattling. We've got enough problems to deal with on this planet as it is without adding any more. Apologies as well. My microphone was crackling a bit before, so I've hopefully moved that to a slightly better position. So if anyone was picking up the crackling, apologies for that. It's one of those things that you look at what's happening, and you look at what's happening in other kind of nation states, like North Korea, for example, are now performing their own launch tests from submarines, and it's only going to get worse and worse. So it really needs brave people, and that's the only way of describing it. Brave people at the top of the political tree to kind of sit down and say, right, we need to stop this. We really need to kind of give this a rest, and as you said, just focus on the peaceful use of space, because at the moment we're trying to encourage the public to look at the benefits of space. You look at COP26, and climate is a key one where we can impress upon the public what the real benefits of space observation and space research are. And it's not just a rich billionaire's playground or William Shatner's kind of wow moment. It's something quite serious. So let's hope. Moving back onto fun things, though, and back to one of our favourite planets, Mars. So this is a great one that Terry found.
Yep, love him or hate him, Elon Musk is intending to go to Mars. And if he does, although he was saying he'd be happy enough to die there, but not just yet, the first crews that go there, I presume, will want to come back. And if you want to come back, you need fuel. And if you want to bring the fuel with you from Earth, it is horrendously expensive. They reckon that the 30 tons of methane and liquid oxygen that NASA would be planning to use would cost $8 billion just to transport that fuel for the return flight to get it out to Mars in the first place. So various people have said, right, can we make fuel from whatever is on Mars? It's not all that easy. For a start, there are no actual fuel factories there at the moment. And the only resources you have really that are useful are whatever's in the region of the surface material, carbon dioxide in the atmosphere, some water, mainly below the surface, and sunlight. So NASA had thought of doing a sort of a compromise where they would transport some of the material to Mars, manufacture the rest there, and that's a sort of a compromise between not having to bring the whole lot there. But now Georgia Tech, which is a leading American research institution, has come up with what they call a biotech solution, or as they say, BioISRU, biological insight in situ resource utilization. And this is quite an innovative, actually. Hasn't been tested in the field yet for obvious reasons, but it looks as if it has potential. What they plan to do is use basically an algae called a cyanobacteria and a specially engineered version of an E. coli bacterium to create fuel on Mars. And how it would work basically is that the algae would convert the carbon dioxide in the atmosphere into sugars, and the E. coli would then convert the sugars to a chemical called 2,3-butane-diol, which can be used as a rocket fuel. And a brilliant bonus from that is that it would also produce quite a lot of free oxygen, pure oxygen in the process. And obviously that's essential if you have a crew there on Mars. Now, it's not just as simple as that. They would need to transport a large amount of plastic to Mars to make photobioreactors, which they say would need to be the size of about 4 football fields. So obviously you can't just go out and do that with a crew of 3 or 4 people. That would need to be done in advance using robots. Then you have sunlight and cyanobacteria and E. coli, which will produce this chemical that you can use as a rocket fuel. There's a fermentation process and then a separation process and so on involved, which I didn't go into in any detail. At the moment, what they are proposing to be able to use based on what they've done on Earth would be too heavy. It would actually be heavier than transporting the fuel there in the first place. But this has been only sort of a demonstration of the principle. They say they're pretty sure that they can reduce the weights considerably, increase the efficiency so you don't need quite so much material and so on, and get it to work. But all they have done really is test this on Earth. They have simulated the amount of sunlight that you would be getting on Mars, which is obviously a lot lower than you get on Earth because Mars is a good bit further away. They need to allow for the fact that the sunlight that reaches the surface of Mars is different from what reaches the surface on Earth because our atmosphere filters out variants that would get through to the surface of Mars. And in particular, they need to allow for the fact that there's a much higher radiation dosage on Mars coming not only from solar radiation, but from cosmic radiation, because the atmosphere there is so thin that it doesn't block that. So they can't be 100% sure that the bacteria, both the cyanobacteria and the E. coli, will actually survive under that radiation bombardment. So there's a lot more work to be done, but in principle, it looks as if it could work, and it's probably not going to be applicable for the first couple of flights, but in the future, if we are having crewed missions to Mars, with people needing to come back again or bringing back research samples or whatever, this is a possible way of doing it. And I know, Nick, you have your own views on Mr. Musk and Mars.
Well, it goes from bad to worse, because first of all, he was going to stick 2,000 hippies on the surface of Mars on a one-way trip on Starship. Now he's going to basically take a pristine biological research environment, something that, we need to understand if life ever existed on the surface of Mars and dump a ton of cyanobacteria and E. coli on it. What could possibly go wrong? I mean, E. coli in itself is, if you know what E. coli is, it's not pleasant. But then on top of that, plastic the size of we're trying to reduce plastic on the Earth. So this is going to have every environmentalist and planetary protection scientist possibly going nuts. Not something you really want, but in terms of, yes, we do need to be able to take fuel from both the lunar surface in particular as well. So mining into the lunar surface and potentially extraction there in terms of fuel generation and using lunar regolith for habitat creation, etc. This is serious research. Same with Mars. You do need radiation protection. You'll need to use the Martian regolith for doing this. There's observations from orbit with various ESA and NASA satellites demonstrating that there is subsurface water, be it slush, be it highly salty brine almost. But there is definitely water subsurface on Mars, and we know that there's still tectonic activity on Mars, and we also know that there's methane coming out of Mars in very unusual hotspots at sporadic times. So could be biological, it may not be, but this is the thing, we don't know. And right now, if it is biological methane, then it'll be one of the most monumental discoveries in human history. The fact that we can absolutely prove that there is life elsewhere than just on the surface of the Earth or on the oceans of the Earth or the upper atmosphere of the Earth. If we are to dump a load of tourists on Mars and a load of dodgy bacteria on Mars, all bets are off. You wouldn't really be able to guarantee that you're not creating a pollutant or an artificial pollutant there. Potentially you could if you drilled down deep enough and you could isolate the core samples from where these methane hotspots are, but it's not ideal and you'll always have skeptics. So proper scientific exploration first, please, rather than just the commercialization of space would be great. Again, it goes back to science, always goes back to science, and moving away from the nefarious uses of space, even military or commercial. Yes, there is a commercial need for space. Yes, there is a lot that can be done commercially up in space. But we need to do exploration when it comes to planetary stuff, in particular Mars, because Mars is probably, along with Enceladus and Europa, one of the three great potential spots for detection of life in our own solar system. So please let us explore it scientifically before we start trashing it, would be my kind of only comment on that one. Anyway, moving on to what's up in the sky. This took on a whole new meaning for me in the last week, because for the first time in 2 years I managed to get out and do some real observing with human beings. So last weekend, where I live in the west of England, they were celebrating the fact that we got dark sky status in North Wessex and an AONB, which is an area of outstanding natural beauty. And the skies near where I live are amazing. It's one of the main reasons I moved out of London to live here. And it was fantastic, as Terry and I both know, because we've done so many of these in the past, but to get back out again and to stand in a field in a dark sky location in Wiltshire, and just hundreds of kids and adults turning up to look through telescopes at Jupiter and Saturn. And it's one of those things that they're both really good and quite low down in the sky. So if you've got young kids in particular in a telescope where, typically most telescopes, if you're looking at high up in the sky, you've got to lift young kids up to the eyepiece and then they can move the eyepiece, etc. The position of Jupiter and Saturn at the moment is quite low to the horizon. So we had a Dobsonian telescope made famous by John Dobson, who used to do a lot of sidewalk astronomy and outreach in the United States. His design, which is a modified Newtonian design, where you've got a Newtonian telescope in a different, far simpler cradle, and you can get really big telescopes for not a lot of money in this design. So I had one of those, and it was just those wow moments, listening to kids walking up to the eyepiece, seeing Saturn for the first time and seeing the rings and just going, wow, that's amazing. And that was with quite a crude telescope by many standards. It wasn't tracking or anything. We had to move it every few minutes, so to keep Saturn in the field of view, and Jupiter. But to be able to see Jupiter's, the stripes, as it were, the cloud backs on Jupiter, and to see 3 of the 4 moons, one clearly not in view at the time, but it was just amazing. And even in the few hours we were there, you could see that the moons had changed position. So it was incredible. And then looking over at the Pleiades, as we were approaching the winter months, you've got the 7 sisters, the Pleiades, appearing. And even in binoculars, that's a stunning thing to look at if you get away from any form of light pollution. And a good test for getting away from light pollution was one that we demonstrated this week in this outreach event, where we could see the Andromeda Galaxy naked eye. So one of the faintest things visible to the naked eye is the Andromeda Galaxy at around about 2 million light years away. And it's one of those great tests of good seeing and good dark sky locations. There are further galaxies now that you can see. So the famous pub quiz of what's the furthest object you can see with the naked eye, it isn't M31. It's, M33 has been seen many times. I know you've seen it, Terry, naked eye. And there's also the occasional gamma ray burst and the afterglow from those, which are in the billions of light years away. So the pub quiz question of M31 isn't real, and I've literally been thrown out of a pub quiz for pointing that out. But it was fantastic. It really was, just getting out and seeing, one amazing shooting star as well that fragmented. So it wasn't quite fireball, but it did break up. It did fragment during our 1 or 2 hours that we were out there observing. And it's one of those things, you've got 2 great planets to look out for at the moment. In fact, you've got more than that, as Terry will probably allude to in a minute. But yeah, it was great. That's all I can say, Terry.
Yep. Talking about pub quiz, I'm going to throw out a quick question, see if anybody comes back with an answer before we go off air. What comes up sideways and goes down upright? But I'll leave that for now. I totally agree with you about Saturn. And the beautiful thing about it at the moment is that, to me, the rings are just at the perfect angle to give you that wow moment. The angle of the rings presented to Earth varies from about plus 28 degrees down to 0, and then 28 degrees on the other side. When they're fully open, it's very impressive, and Saturn's very bright to look at. But it's not just as aesthetically beautiful. When the rings are edge on, you can barely see them. At the moment, the tilt is just about right. And you see Saturn through a telescope at the moment, you will go, wow. Jupiter, as you say, fascinating, and as I was saying earlier, always something different to see on it. So I totally agree. For what I want to cover and look up, we're actually going to go in the other direction. The 2 planets that are closest to the sun, and they're actually on opposite sides of the sun as we see them from Earth here at the moment. That means that one's visible in the evening sky and the other in the morning sky. So we'll start with the evening sky. That's the easiest. Venus, the brightest object in the night sky after the moon, apart from the occasional very, very bright fireball. It's low down in the southwest twilight. To be absolutely honest, if you're in the northern part of the UK, Ireland, it's quite difficult to see because it is so low down, but it's getting gradually slightly higher up. If you're in the southern part of the country, you will be able to see it much more easily. But there's a couple of occasions coming up in the next couple of days, week, when you get a much better chance to be able to locate it. On the 7th of November, it will lie just to the left of the crescent moon. On the 8th of November, the moon is moved and Venus will be just to the right of the moon. And then the moon moves on. And if you can't identify the other planets, on the 10th of November, it will be lying just below Saturn. And then the following night, the 11th of November, it will be lying just below Jupiter. And you'll notice just how much brighter Jupiter is than Saturn. So that's the early evening sky. You need to get out just as soon as the sky is starting to get dark, because Venus will set once you're into really late twilight. But you'll see a very bright star-like point down near the southwest horizon. Then going even further into the sun, Mercury, the closest planet to the sun, visible in the mornings. And by chance, tomorrow morning, just about 45 minutes before sunrise, start looking and you will see that it is just below and slightly left of the crescent moon. So the moon isn't moving in opposite directions. I'm talking about tomorrow morning for Mercury, and then 7th of November when the moon will have moved on past the sun and it will be starting to pass by Venus. So then on Thursday morning, the moon will have moved even closer to becoming a new moon. It will be extremely faint, very, very thin crescent, difficult to see. You'll need a perfectly clear horizon right down to the southeast. Again, start looking about 45 minutes up to 30 minutes before sunrise, and you may just see the moon even closer to the sun than Mercury, which is relatively difficult to do. So those are 2 chances over the next couple of days to see the 2 innermost planets. Venus usually is much, much easier to see than it is at the moment, but have a go anyway. Mercury, if you don't mind being up in the morning, this is a good chance to see it. And then coming on to sort of the starlight wonders of the sky. In many ways, this is my favorite time of the year, because if you're out early, you can still see the summer triangle and things like that. And you wait a bit later and you're seeing all the glories of the winter sky. So the first thing that'll appear above the horizon are the Pleiades, or the Seven Sisters, in the east and northeast. That'll be followed by Aldebaran, an orange giant star coming up, and a smaller, well, actually a bigger but fainter cluster of stars surrounding it, the Hyades. And then the answer to the quiz question, and I don't see any answers coming up yet. But what comes up on its side and goes down upright is Gemini, the twins, the constellation of the twins. And just by the way the sky turns as the Earth rotates, Gemini comes up with the two twins, if you like, Castor and Pollux, lying on their side. But then as they set in the west, they actually set feet first, because the sky is rotated. And after Gemini coming up, you see the top of Orion coming up, the fainter star Bellatrix, and then the red supergiant Betelgeuse following that. And once you see Orion, you know winter's here. That's it.
Absolutely. The other thing that we may want to mention, Terry, because just before our next show is going to be approaching the peak of the Leonid meteor shower, so keeping an eye out. And as I said, just out the other night, we were well past the peak of the Orionid meteor shower, but we were seeing some absolutely tremendous, almost fireball scale kind of meteors streaking across the sky. And obviously you can also see the satellites as well. Not that in some cases you may want to. Starlinks have now kind of largely disappeared from the sky because the sun shields that Elon Musk has put on them to keep them out of sight, out of mind for the general public. But there's still lots of satellites to see. We're not in a great ISS kind of transit period at the moment in the UK, but it's one of those things that keep an eye out all the time. You get the occasional flaring as well of satellites, where they'll pick up the sunlight with a incident solar panel reflection, and they'll become incredibly bright just for a matter of seconds. So it's one of those things just to keep an eye out for as well all the time. But do look out, and this was the great thing. We're approaching Christmas. Everything's a little bit strained at the moment, and it's just one of those great free things you can do. Anyone can go out with a flask of tea, coffee, whatever, sit in a deck chair or sit in a chair in the back garden, just look up and look at the wonders of the night sky. And getting your kids a telescopes approaching Christmas time now, always a great fun thing to do. Make sure you get a good one. Don't get one of those rickety ones, because it'll put people off. As Terry was saying earlier before he came on air, kind of early experiences really do matter with astronomy. And if you're disappointed, and one of the key disappointments many people get is a nasty, rickety, like cheap telescope that they're horrible. The ones that you see with pictures from the Hubble Space Telescope on the outside, and then you point it at something and it looks like a grey fuzzy blob. Try and spend a little bit more, get a half decent telescope, and trust me, you'll have both the adults and the kids in your family obsessed for life, because they're wonderful things to see. That's it for this show. So we'll be back in a couple of weeks' time. I'll hand you back to our amazing friends at Space Store. Again, cheers for the T-shirts. We do love our T-shirts. Space Store have got some exciting news. I don't know if I can tell you about things that are coming up with them. And they do great outreach all the time. I mean, we do this show every 2 weeks. They're fantastic in hosting it for us. We're so grateful. And we know we get comments on Twitter and whatever saying that they've enjoyed the show. Massive thank you to anyone who's been listening tonight at Ground-Based Space again for your Kerbal enthusiasm. Kerbal is a kind of way to kind of play at being a rocket designer, etc. And he's got 2 satellites called Nick and Terry, one of which apparently is getting a bit close to Mars, or Kerbал's version of Mars, so he's going to keep us updated on that. But just a massive thank you, and I'll hand you back.
Nice, awesome. Thank you so much, Nick and Terry. It was another great show. Thanks again, everyone who's tuned in tonight. Remember, you can catch up with all of our previous roundups on the YouTube channel. So please go ahead and hit subscribe there if you haven't already. And as Nick said, we'll be back in a couple of weeks' time with more space news. Same time, same place at 7:30 p.m. I hope everyone's got used to the clocks going back. Oh, are they going forward? Forward? Back? Oh, so I'm still confused.
Just bring back to you. Back to the fall. Easiest way to remember.
Well, yeah. Make sure you're here on time in a couple of weeks. Until then, enjoy looking up. Take care and have a great evening. Thanks, Nick and Terry.
Stay safe.
Cheers, everybody. Bye-bye.
Bye.
Bye.
Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the space stuff. Adios, amigos.
Bye all.